Well, thank you, everyone. Thanks so much for coming, taking the time out. Marcus, thanks for coming all the way from Switzerland. I've worked with Marcus a little bit on frost tubes, so it's always great to connect with you. Um, I'll try to rest my voice. I've had an illness, but this has kept me going because I've been looking at snow pictures all week. And I'm really excited to present with everyone today. Let me go ahead and share my slides. And hopefully they're sharing. What are you seeing? Are you seeing my speaker notes or are you seeing the slides? Great.
Slides.
Awesome. Thanks so much. So I'm Christi Buffington, and today's water cooler, the whole thought of a water cooler makes me happy because I'm thinking of drinking cold water and meeting with all of you. Maybe if you're a teacher in the teacher's lounge, if you're a scientist, you get out of your cubicle or your office and you go and talk to people about science. So this is a really great metaphor for what we're doing today. Today's kind of what we've learned from the SnowView globe, photos of snow and clouds, trees, and on land intensive observing period this February. And I really want to share thanks to Peter Nelson, the co-lead of this intensive observing period. Now, my time and my work is supported by a grant, Globe Alaska and NASA SnowX reciprocal mentoring and collaboration. And I work at the University of Alaska Fairbanks Tratheta campus, and I work in the Geophysical Institute at the Geographic Information Network of Alaska and partner with so many of you. So thank you for coming and thanks for inspiring me. For those of you who are maybe listening to the recording or are new to GLOBE, GLOBE stands for Global Learning and Observations to Benefit the Environment. It's 30 years old. And there are two ways that people can submit observations. They can be trained GLOBE observers and use, excuse me, GLOBE protocols, or they can use the app. So to be a trained GLOBE observer, you have to either do training online or in person. Otherwise, anyone can get the GLOBE Observer app on their phone and participate. Today, I pulled data on how many countries are participating in GLOBE. There's 127 countries, over 42,000 schools or informal education organizations. 43,090, that means those are that many people, over 53,000 people have gotten GLOBE training. Over 290,000 are GLOBE observers. They do get training. It's just through the app so that they are trained how to do observations in the app. And wow, you know, over 260 million measurements. And just this month, over 1 million. That's so cool. I wanted to share some of the snow observations that have come in this month. This is the first time I've ever done anything like this, leading an intensive observing period for snow. It's international. And I was traveling for 2 weeks this month, and then I got sick and I'm like, what's going to happen? Is anybody going to do this? But you know what? GLOBE is huge and it's amazing. And so many of you here on this call have contributed observations. So thank you so much. Let's look at the first 20 days. What are you seeing? You're seeing little snowflakes. Those are for actual GLOBE protocol for snow depth or new snow. And then the little squares that you're seeing are land cover photos from the GLOBE Observer app land cover tool. So you can see that people have participated all over the world. And Marcus, I can see your observations in Switzerland. I'm really interested in Alaska. So that's where I live, right? That's where Tori lives as well. So here we are in Alaska. I wanted to figure out why that little video had a big square right around Fairbanks. And it's because there were so many people doing globe um, land cover observations in this interior Alaska region. We also had people in Homer, Alaska, and Anchorage doing the snow protocol for snowpack depth. And we did have a handful of people measuring new snow, which requires a snowboard and more equipment, and also a rain gauge. I did look at these pictures. We decided to have some data about what we're learning from these observations in April. I know like who's been participating, but I do just want to share that there are 3 more days to submit observations. And today I'll cover a little bit what we need up in Alaska and why, and then also connect to what's really useful for around the world with linking to satellite observations. So how did this SnowView intensive observing period come about? It really snowballed from multiple people collecting data from students, starting with students, NASA Snow X campaign scientists, and then people who are doing satellite remote sensing. So I want to share that snowball story of how this like started with a few things and snowballed and caught momentum and became bigger and bigger. I also want to show what we're doing outside, like the GO. I love that globe observer is go. So we want people to go outside. What you've seen on the app and on the website has been really focused on using Globe Observer, and it's been really focused on the land cover tool. But it's also important to know that the clouds and the tree observations do tell us a lot about snow and the water cycle. Snow comes from the clouds, so that's like a given. But then trees may intercept snow, and snow that never even, if you've ever stood under a tree when it's raining and you've been totally dry, you have experienced interception. That's part of the water cycle where snow that is precipitation or rain that is precipitation never touches the ground. So we want to know how much interception there is. And we can do that through, we can get a great idea through these photos of trees. All right, so that's this part. Should have reversed these. But in Alaska, we're actually asking people to do a little bit more. And we do need this in the lower 48 and across the world as well, and in Canada. And we want people to go out and measure how much water is in the snow and how deep is the snow. In Alaska, we were hoping to do this in February during a snow event. But you know what? It didn't snow. And then if we have time in this webinar, I'll share some really great snow learning resources that you can use with students. So I mentioned that this snowballed, it was really inspired by students in Kikikak or Shishmaref, Alaska. I got a phone call from their teacher, Robin Ichuak, in probably 2020. And she said, I've got a student who really wants to work for NASA someday. And I'm paraphrasing, I'm not quoting exactly. And she's like, how can we find a globe investigation that relates to what the students are interested in? And, you know, how can we connect the student to a NASA scientist so that that person can see themselves working at NASA someday? So that's like the seed, that's the start, that condensation nuclei in the cloud from which an ice crystal started to develop, which then got bounced around and became a snowflake eventually, or a snow crystal. And here you see one of these students was the student who wanted to work at NASA someday. And this was when the student was a middle schooler, the student's a high schooler now. And this picture is of a snowdrift that formed overnight. You may know that the ice in the Bering Sea is frozen anymore, and that's causing a lot increased winds. And during a big storm event with high winds, this snowdrift formed. And so these students went out to collect snow depth and use globe and started playing on the drift while they were going out to their site. So they're the ones who inspired me and so many others to work on snow. So what was their motivation? Why go out and sample snow? Well, they wanted to know if the snow was clean. That where they live, snow melt is the drinking water supply. It melts in, it's a barrier island without any lakes or rivers. So snow melt is the drinking water source, and the snow is collected in a lined pond. So the students went out and sampled snow for what is in it and light absorbing particles in the snow. Then they wanted to know, like, what's happening, like all these particles in the snow, they affect the energy cycle, because that means that they're affecting how the snow melts, because those particles absorb heat. And then, of course, we know that snow affects the energy cycle through the processes of melting, through flowing as liquid water later. And they also wanted to understand the process of snow melt. Now, this graphic was made by Kayla Bannister, the former NASA SnowX intern, and she's an alumna of UAF, and she was a former student in my watershed management class. She made this when she was a NASA SnowX intern. And these are some of the reasons that motivated her to study snow. And I'm gonna maybe provide the links so that people can see her project as well. She'd made a GIS story map of her Dirty Snow Globe project. So her methods and Kayla Bannister's methods and the students in Shishmaref were collecting snow and filtering it. For those of you in education, I wanted to share about that energy, how snow affects the energy, cycle, the flow of energy as matter cycles. And this is the next generation science standards for middle school. These standards say that students should be able to plan an investigation to determine the relationships among an energy transferred or the type of matter, the mass, the change in the average kinetic energy, that's the energy of movement, as measured by the temperature of the sample. Well, guess what? We do that in globe. If you take a temperature of the snow with the surface temperature, probe, you are measuring temperature and reflectance. In light absorbing heating method that the students in Shishmaref and also Kayla Bannister utilized, that was invented by Dr. Carl Schmidt here at UAF, does just that. So here's one of the filters of the snow, and it's in this this LAM machine, and all it is basically an infrared thermometer that shine a light on the filter, and then you take the temperature of the filter as it heats up, and then you take the temperature as it cools down, and this is automated in real time. And then from that, it's compared to how many what the mass of light absorbing particles on the snow is, and then we can compare that to the albedo as well. There are some research papers on this method. So I just want to share that by doing this work, the students in Shishmaref, Alaska, found out that the cleanest water source in their community, the least amount of in micrograms per liter filtered was at their drinking water source, but it was the dirtiest at the airport runway. And that's also where they gather their berries. Okay, so I mentioned that the intern working on light absorbing particles was inspired by these middle school students because I shared their story in my undergrad course. She's like, I want to filter, like if the middle schoolers can filter snow, I want to filter snow too. So then she inspired her mentors, who Dr. Carrie Voyevich, the lead scientist for the NASA SnowX campaign, met with me and Dr. Alicia Joseph at NASA, and also the intern Kayla Bannister, and that's how they learned about the dirty snow. And meanwhile, we were preparing for the Alaska SnowX field campaign. So SnowX is a multi-year experiment that's sponsored by NASA. It's using different technologies, remote sensing and field technologies, alongside people who are collecting data on the ground. And the red dots show all the places where snow has been observed and data have been collected. On the legend on the left, you see what's called snow classes. Notice how similar they are to our Globe Observer land cover classification. Note that tundra snow is not necessarily only snow that falls in the tundra. You could have tundra snow anywhere in the world. It's just that the snow has certain characteristics that are common with snow that typically falls in the tundra. So these 7 different snow classes were big gaps in the understanding, and one of the motivations for NASA SnowX to study how the global water cycle is affected by snow in these regions and how snow is changing, especially how much water is in that snow during the melt periods in March and April. Okay, so what's super cool is that the NASA SnowX scientists, when they came to Alaska in 2023, they wanted training in GLOBE. So I had the honor of training 40 scientists in using both GLOBE Observer, land cover, and I gave them opportunity to get trained in actually the GLOBE solid precipitation protocols as well, which they did the e-training for. And you can see that Dr. Carrie Voyevich collected GLOBE data, and you can find her data in the GLOBE database. This is in a webinar that we gave together that's linked on the SnowView IOP page. And on the left, you see the current SnowX intern, Julia White. And this is her path to science. But what I'm showing here is a snippet of this video. NASA SnowX scientist Dr. Carrie Voyevich also uses the Globe Observer app. She has precipitation, snow depth, cloud observations, all under the Globe atmosphere protocols. Under land cover, you can see pictures from the snow pit sites from up, down, in each cardinal direction. So how do we find these snow depth and land cover photos in the Globe visualization system? We have to select snowpack depth under atmosphere protocols and land cover photos under biosphere protocols, and then click the submit button. Okay, what you see here is just lots of the data here in Fairbanks, Alaska. But this here is Carrie Voyevich. This is the NASA SnowX data alongside the GLOBE student collected data, which they were doing observations there in Kramer's field. This around a lake, these were all student data. So you can see how cool is that the snowpack depth of their snow pits, that data is in GLOBE, and it's the NASA SnowX campaign data, and it's right alongside all of the student collected data and observer collected data as well. All right, so now we have a new SnowX mentor intern, Julia White. And Julia was really interested in Delta Junction, Alaska. So we learned that SnowX also flew and collected data in Delta Junction. And here is their path where they were doing remote sensing and field studies. The red lines are where they did transects and field studies. And then the whole box is where they flew an airborne campaign. So that's kind of like sharing the background of like why starting with 7th graders in Kikitac or Shishmaref, Alaska, motivated my student who then became a NASA SnowX intern, who then like helped train NASA scientists, who then wanted to keep it going and keep learning about GLOBE. And now we have this SnowView IOP focusing and starting here in Delta Junction, Alaska, from a visit that Julia White, Tori Brandon, who's on this call, and I did in November. Now, we didn't know in November when we visited the school that we'd be helping lead an international intensive observing period for snow. That came about because we came back and said, oh my gosh, you know, here's what we're doing. And we shared what the students were interested in with Peter Nelson. And he had the idea to like, let's do this. The GLOBE, the logo I want to share is yet another student who's involved. A former student from my class who works at Geographic Information Network of Alaska, GINA, is Michelle Morris. I encourage you to look at the logo and read about how she came up with it. And I'll share another image of what she came up with and what the needs are for how we collect data and share that data, and how geospatial analysts and remote sensing scientists can actually use our GLOBE data to make it useful. I was working this last fall with Michelle Morris, or Mimo, and I had been in a teacher in a, when I was a teacher, I used the Wiggins and McTighe GRASPS format. I'm sorry that I can't remember what the acronym means, but it's basically like giving someone a prompt so that they, or give them a place-based or problem-based learning project where they see themselves as the scientist. Now, Michelle Morris has perspectives of both being a student, a former student in my class, but she's also a GIS specialist and a geospatial, in the role of a geospatial analyst, where we work at GINA. So I gave her this prompt. I said, okay, you are a geospatial analyst. Your task is to link satellite collected data with ground-based observations and data. Your task is to find proper ground-based observations and data that correspond with your satellite data. And that's all I told her. And what she was doing is she was going through all of the different snow participatory science projects that are out there. And there's many projects that are collecting data on snow. So she came up with this drawing, this graphic, because there's a lot of projects all collecting slightly different things. And I wanted to share this here because this is our challenge, right? With GLOBE. Here we use a rain gauge and we use the metric system, and we're asking people to measure snow in millimeters. Here's the ruler. Just imagine going out and measuring snow and saying, okay, go out and collect a snow depth. People are going to give you data in inches, but GLOBE is going to use the metric system. And we want data actually in millimeters and not in centimeters. That means that we have to, like in the US, teach the metric system. And then we see, this ruler It's got both imperial and metric units. And then other, if you go to the National Weather Service data in the United States, those units are in the imperial units, they're in inches. If you go to the other participatory science projects, they're also in inches. And so this little rain gauge, there are many, many people who have it in for globe. That inner tube inside of it in globe is in the metric system. The exact same instrument that is used by a program called COCORA's, Community Collaborative Rain, Hail, and Snow, has it in 1/10 of an inch. So people need to know what tools they have and how to measure it. So she really honed this in for me, that I'm like, okay, we gotta like make it easier to, these are her words. She said, okay, it's not easy to access data in all these myriad citizen and participatory science projects. There are different units. There are not uniform protocols, but some protocols are restrictive. So these are the things that we all, as scientists and as educators, have to make easier, but also very clear for GLOBE participants. So I would love, after the IOP, for Memo to do a new graphic to show that hopefully it's not such a headache to try to work with all these data. Okay. How am I doing? Okay, I need to speed up so that we can get to some cool questions. I mentioned that I work at GINA, Geographic Information Network of Alaska. I've shown here Michelle Morris, or Memo. Another undergraduate we work with is Grace Veenstra. And those are some people I want to highlight in the rest of this talk, as well as Carl Dirking, who's a forecast meteorologist. And what is GINA? It is a direct satellite downlink and broadcast facility. We own these antennas, and we receive satellite data throughout the day, many times over. And within as fast as 8 minutes of an overpass, we have products that are usable, especially in the forecasting and satellite remote sensing world. But I really want to thank, like, GINA is all about what makes all these data possible are the people behind it. So I mentioned Grace Veenstra is an undergraduate student, and honored to work with her. She's also trained in GLOBE and a participant of the project Fresh Eyes on Ice. She wrote this article, Satellites and Snowfall, Developing Innovative New Products Across Land, Sea, and Sky. And it got Carl Dirking, the satellite forecast meteorologist, and I talking about this SnowView IOP. Can we use the GLOBE observations that people do to compare to the snowfall rate product that we help to produce at GINA along with the University of Maryland? So I've got a little bit of time. I need to rest my voice. I'm going to let Carl tell you about what we were asking people to do if it were going to snow in Alaska this month for the SnowView IOP. And we were asking them to use a snowboard, which we cut and painted and made 28 of early this month for this IOP, and a rain gauge. So let's listen to Carl explain. Oops. All right, I can't play his video, so I'm gonna go ahead and I have to pass it. But what you could see here, he was describing how important polar orbiters are. Many of you in the lower 48 utilize data from stationary satellites, which are orbiting around the same time as that the Earth is turning. And so they're getting kind of the same view of the Earth. Polar orbiters then get data also around the whole Earth, but then they are covering the poles that are kind of skewed in those stationary, geostationary satellites. So the Alaska snowfall rain and rate product, you can see these pixels, and their different colors show what's happening. Snow showers, steady snow, and steady rain. And that during a snow event, it actually tells you how much water, liquid water equivalent, is in the snow per hour. And that's what we wanted people to go out and measure throughout the day at their schools or other organizations. It's like, how much is it actually snowing per hour? And then at the end of the day, just once a day, go collect the snow on the rain gauge, melt it down, and find out what the liquid equivalent is. So we hope to do this someday. We just need snow and people. A little bit, another thing that came up, and this came up from remote sensing scientist Bill Line, a meteorologist Bill Line, who works with the, he'll be in the next slide. But we were looking for blowing snow photos. You know, have you ever, I used to live in Montana, and I get these alerts on my app saying, don't drive today, there's blowing snow. And I didn't really know what that meant. So what does that mean? Well, there's a difference between drifting snow and blowing snow. Blowing snow is lofted into the air, reducing visibility. So you can't really see, right? Travel's hazardous. The roads are going to be snow covered and slick. Drifting snow is also hazardous, but the snow can melt on the roads and refreeze. It's really, really common. So satellites can pick up on blowing snow as well. And at GINA, we work with meteorologists elsewhere as well, such as Bill Line, for using satellite imagery for sea spray, blowing snow, and water vapor detection. And he gave a presentation that I helped moderate. And I asked him, do you think that you could use photos from globe observers? You know, they're on the ground, and if they have a globe observer land cover photo and there's no visibility, do you care? Could you use that? He's like, yes, absolutely. And he even showed how not webcams, but those real-time cams from the Department of Transportation are used. It would be great to have imagery that are collected by globe observers so that we can compare it to these models. Okay. Now to actually the IOP. Here are some photos in Delta Junction of students using the rain gauge to collect the amount of snow in the total, total snowpack. And then they would take that down, melt it down. And this is them collecting the depth in millimeters. They were looking at a snowdrift. And I just really hope that you can come on Friday to the conversations that these students are going to have with Julia White, the SnowX intern, who's pictured here, climbing on a glacier, and with Dr. Carrie Voyevich. Julia was motivated. She's working with these students because she is studying the same exact snowdrift from space using remote sensing data. She wants to know how deep is the drift and how much water is in the snowdrift. So these students at the school are measuring those. They are there, and she is finding various satellite imagery to help answer that question as well. And I'm super excited. Lots of conversations yesterday between Julia and the teacher, Tammy Kovalenko, about Friday's Meet the Scientist webinar. I really hope you can make it. We also have participants across Alaska who've been measuring snow. I really want to give a shout out to Henry Rieske from the Center for Alaska Coastal Studies. This is several years ago. He first trained in Globe, and he's like, sure, yeah, we can do this. And he went ahead with the rain gauge and made a video of how to collect snow with the rain gauge and a snowboard for the new snowfall protocol. I'm gonna pass through that. I know we have a few minutes left. I do have additional slides about really great lesson plans and wonderful things that you could do in your classroom, including in Inupiaq language and Globe Grammar. But I also think this might be a really great time to stop and let's just talk snow. I would love to hear from all of you because again, this is the first time that I've ever helped lead an international intensive observing period for snow. Oh, and I see Tammy, you're on the call. So yay, Tammy Kovalenko, thank you. And I just want to give a chance to turn it back to you, Jody, and allow people to ask questions and let's talk.
That's great, Christy. And if you want to send me, if there's some things that you would like to have them have access to, your slides and so forth, you can send me that and we'll package it together when we make the recording available. So they can still get to all your goodies that you didn't have time for. Let's open it up to questions.
Right, I'll stop sharing. And I didn't get to keep that up. I already just stopped sharing, but I forgot to thank everybody. I want to thank Arctic and Earth Science, Arctic and Earth 7 Integrating Globe and NASA project, of which Tori is joining for at International Arctic Research Center, where I got my start. It's a NASA SciAct funded project, and like so many other partners as well. And Allison, Allison Moat, thank you for carrying the SnowView IOP, these webinars that you're doing, and then also just like getting the word out. You've made this actually happen and you've prompted me when you needed something. So thank you so much. All right, now you can ask questions.
Yeah, there were a couple links that I missed. Really, I was trying to really take some notes, but probably like, I don't know, missed one or two letters and couldn't really get to that link. I don't know if it's possible. You don't have to do it now, but I just want to thank you, Christy. It's just fantastic. For those of you who know where I'm coming from, I dealt with the snow since I was born. So it's really for those of you who experienced the temperatures similar to Alaska, like I did. So that's really fascinating area of research. Thank you, Christy. Fantastic work. Thank you, thank you, thank you.
Thanks so much, Larissa. I'm going to start plopping links into the chat.
Any other questions for Christy or comments?
I'm curious about you mentioned there about the middle schoolers filtering the snow. How do they actually go about doing that?
Oh, thanks so much for asking. So the link that I'm posting right in the chat right now by Kayla Bannister is her GIS story map, and it shows the step-by-step process for filtering the snow. We actually have a whole series of videos as well. And here's what they do. We use a 30 by 30 centimeter, actually double check with my ruler. Yeah, square. And we get just the top 3 centimeters and we pull that in the snow. So we put the square in the snow. Sorry, I talk with my hands here. And then we scoop that snow in the center. We take it inside. So collect that, take that inside, melt it. And then after it's melted, putting in a 60 milliliter syringe. And then we use a syringe filter holder that has a quartz fiber filter on it. And I'll have to get, it shows in the story map that I just put in the chat, what size that filters out of those particles. So what it does is collects the light absorbing particles on that filter, and then they continue to do that until they've filtered their entire sample. So what's happening is that as snow melts, the particles stay on the surface. They tend not to go through the snow column. So hopefully her story map will help explain that process further.
But can I just ask a follow-on question with that? Do you want snow that's freshly fallen, as opposed to the snow that's been sitting, that's been snow plowed on the on the side of the road?
Yeah, that's a really great question. We developed a protocol, and Kayla actually typed it up as like using Globe protocol as her template. And we don't want the snow that's been plowed up, because that's gonna have all the stuff from the road. What we want is far enough away from the road. And then freshly fallen snow is super interesting. So Kayla continued to sample. So she has a big time series, and I helped her collect the data. I'm actually the one that gets to publish her data, or our data rather, to the NASA DAC, or data archive. And what she found is that sometimes there are particles that are in the snow itself as it's falling. So what you just asked, do you want this or that? Do you want freshly fallen snow or snow that's been sitting around? Well, it's kind of up to what the researcher wants. Like if you want to know if the snow that's falling is dirty, then filter the freshly fallen snow. If you want to find out what's on the snow in a melt period when it's not snowing at all, that's another research question. So both, it depends on what your needs are. And check out her story map. She actually like shows that it got dirtier with fresh fallen snow at one point. And we're like, what?
But let's take a moment to thank Christi. Christi, we know you're not feeling well, so this was for sure above and beyond the duty. And it was fantastic. We all, I think, enjoyed and learned a lot.